So in the last class, I gave one question. First, we will discuss the question, and after that, so these were the questions I gave in the last class. This compound is reacted with hydroxylamine, and it is said that two products are getting formed. So if you see this reaction, here you will be able to get two products only when the reaction happens with this, then that oxime of ketone will be formed, and that oxime of ketone can so geometrical and considered as two products. So just write the product here, and you know how to write the product in this case. You need to be connected to this carbon by double. Writing the product. So there are two geometrical isomers which are going to be formed here. Now, it is said that out of these two, one on reaction with sodium gives cyclic product. So one of these two on reaction with sodium gives cyclic product, and that isomer has been named as P. So we have to identify out of these two which will give cyclic product on reaction with sodium. So here you see, on this benzene ring, nucleophilic substitution is possible. If you see this part only, just this part, then this is para-chloronitrobenzene. We have very strong minus R group at para position with respect to chlorine. So nucleophilic substitution reaction is possible here. This can give AR-SN reaction. This chlorine can be replaced by nucleophile. Now, if you see these two isomers, obviously in this isomer that nucleophilic substitution reaction is possible. Here is the nucleophile. Here nucleophile is on the opposite side. So in nucleophilic substitution reaction is difficult. But in this case, the nucleophile OH is on the same side. This OH and chlorine, they are on the same side of double bond. Since OH and chlorine are on the same side of double bond, nucleophilic substitution can easily happen. Here that nucleophilic substitution is difficult because OH and this chlorine, they are on the opposite side of the double bond. So This is the isomer which can give nucleophilic substitution reaction. Now see, when it is reacted with sodium, it is OH group which is going to react with sodium. You know, alcohol reacts with sodium and forms alkoxide. So reaction with sodium, it will first form alkoxide. Now this alkoxide will attack on this carbon atom of benzene ring and this chlorine will be replaced. This is only ARSN, aromatic nucleophilic substitution reaction. And you will get a cyclic product. This product is U and this is P. Now, this product is Q, which does not give cyclic product. Now, in the question, this Q has been reacted with acid. So this is oxygen. If it is reacted with acid, then Beckmann's rearrangement will take place. Now, you need to write the mechanism for Beckmann's rearrangement. Just to try to recall in details. In Beckmann's rearrangement, first this OH gets protonated by H+, it becomes OH2+. Then that OH2+ departs from here and positive charge develops from nitrogen. And after development of positive charge on nitrogen, one of the group migrates from this carbon to nitrogen. And this we have discussed which group is going to migrate. So can anyone tell which group will be migrating here?
Anti-to-OH.
Anti-to-OH. So group which is anti-to-OH that will be migrating means this benzene ring, this will be migrating. Methyl won't migrate, this will migrate. This benzene ring entire part will migrate from carbon to nitrogen. And I will directly write the product. You can write the steps and check. This product should come. So after Beckmann's rearrangement, this product will come. Now this product is named as R. Now next this R is hydrolyzed. You know, when you hydrolyze it, this amide will undergo hydrolysis and this CO end bond will break. Now if you break this bond, then CH3C double bond O, that will come out as CH3COH. When it is reacted with sodium bicarbonate, you will get carbon dioxide gas. So this product is T, and other product of hydrolysis will be the corresponding amine. This is S. This was the question which I gave in the last class. to this question. For the statements, I have written these 4 options. You have to identify the correct statements, correct options. There is a compound X of molecular formula C2H5NO2, which on treatment with nitrous acid gives off a gas Y and forms Z. With soda lime, X gives A, having formula CH5N, which is soluble in acid. Now identify the correct statements. A, B, C, D, 4 options are there. Identify the correct options.
ABD.
ABD.
Yes.
See, we are getting some clue from here that this compound on treatment with nitrous acid gives off a gas Y. You know, the reaction with nitrous acid, NaNO2HCl, that is basically given by amines, and if it is primary amine, then it will undergo diazotization, and from there you will get nitrogen gas. So from this information, we are able to understand that this may be primary amine. Now read second line. It is said that when heated with soda lime, X gives A, which is soluble in acid. Reaction with soda lime, that is the characteristic of salt of carboxylic acid, or you can say that is the characteristic of carboxylic acid. When salt of carboxylic acid is heated with soda lime, carbon dioxide gas will be released. Decarboxylation will happen. So here, you see C2H5NO2, one thing is very clear that it is amine, and from second statement we are able to understand that it contains carboxylic acid also. So just to try to write the formula, if it has carboxylic acid group, then it will be having this COH, and after that you are left with only one more carbon, and NH2 group should also be there. So this is the only one possibility. You check the molecular formula, you have 2 carbon, 5 hydrogen, so 2 plus 2, 4 plus 1, 5, 1 nitrogen and 2 oxygen. So your compound X is this. When it reacted with this nitrous acid, NaNO2HCl, reaction will happen here, and you will get this product. Gas which will be released will be nitrogen gas. So gas is Y, the product is Z. Now when it is heated with soda lime, decarboxylation will happen, and you will get this product, methylamine. It is said that compound A is more basic than acetamide, methylamine is more basic than acetamide. Amides are hardly basic, they are basically neutral. So this is correct. X is amino acid, this is amino acid glycine. Y is carbon dioxide, it's wrong, it is nitrogen. Z is hydroxycarboxylic acid, this is hydroxycarboxylic. So I've written these 4 compounds. You have to identify the compounds which on reaction with sodium hydroxide solution can give methanol.
BD, sir.
Which one?
BD, sir. BD.
BD. All of you do it. This is one direct question based on SN1, SN2 kind of reactions. So answers are B and D. See, if this compound, this one is reacted with hydroxide. How the reaction will take place here? Where that hydroxide will attack?
Sulfur.
Will attack what? Sulfur. Then pi bond will move to oxygen. Here negative charge will come. Then that negative charge will come back and then this sulfur oxygen bond will break. So this way the reaction will happen. So what product will you get here?
Phenol and methyl sulfuric acid.
Methyl sulfonic acid and phenol. Means that paracresol. Paracresol. So you are going to get methyl sulfonic acid and paracresol. You want to get methanol. Here, when this is reacted with OH minus, where this OH minus will attack? Will it attack on this carbon or it will attack on sulfur?
Sulfur.
Sulfur. So if it attacks on sulfur, will you get methanol or you will get that sulfonic acid and methoxide? Okay, that methoxide can also again take H plus from sulfonic acid and that will become methanol. So anyway, you are going to get methanol here, but my question is where this OH minus will go? Will it go to carbon or it will go to sulfur?
Carbon. It is like patient to
It
attack
should
on
go to carbon. You can understand this way also. Suppose if it goes to carbon, what is the living group? Living group will be this tosylate ion, very, very good living group. And if it goes to, if it attacks on the sulfur, what is the living group?
OCH3 minus.
Living group will be OCH3 minus methoxide, which hardly behaves as living group. You know, methoxide, this will hardly behave as living group. This very strong base. Here, it can depart as O minus. This is a relatively better living group because you see this negative charge will be in conjugation with this benzene ring. So here negative charge is relatively stable. So it can come out as leaving group. But from here, departure of this methoxide as leaving group is almost impossible. That is very, very difficult. So this OH minus is going to attack on carbon and this will depart. This will be the leaving group. So you will get methanol and that sulfonate. Now, when this compound is reacted with hydroxide, here we do not have many possibilities and this is very simple. Actually, which compound is this? Is it ester?
Yes. Yes, sir.
Ester. Yes. So where are we expecting this hydroxide to attack? This CO group.
Yes.
So hydroxide will attack on this CO group. You cannot get methyl alcohol there. Now see this quaternary ammonium iodide, when it is reacted with sodium hydroxide solution, this hydroxide will attack on carbon atom of one of the methyl group and remaining part will come out as leaving group. You see this N plus bonded to this 3 methyl. This part will be very good leaving group. Once it comes out, it will become a highly stable tertiary amine, which is a neutral molecule. That normal SN2 reaction is going to happen. So you will get methyl alcohol and this trimethylamine.
Sir, yes, sir.
You have to identify the intermediates in Hofmann's bromide reaction.
ABC.
ABC. Okay. All we do is just to think for 1 minute. Recall the mechanism.
Yes, sir, ABC.
Sorry, AC, sir.
AC. Okay, I will tell the answer.
Only A, sir. Sir, in above option C, is there a double bond between N and C?
Double bond between?
N and C, option C. Above.
Yeah, double bond. Yeah, double bond is there.
Then AC, sir.
Tell the answers.
First one is AC, sir.
First one is AC.
Yes, sir.
Second one is BC. Sir. Sir, is the second one BC?
Second one is
BC.
B and C.
Yes.
Yes, sir.
So first one is Hofmann's bromide reaction. This is one intermediate, and in Hofmann's bromide reaction, this isocyanate is also formed as the intermediate compound. You know, this only on hydrolysis base gives primary amine and carbon dioxide. This is never formed. Now, doubt is about this nitrene, acyl nitrene. Is it formed in Hofmann's bromide reaction or not formed?
Not formed.
Not formed. Do you remember the reaction where this kind of intermediate, nitrene intermediate is formed?
Curtis rearrangement.
Curtis rearrangement it is formed. In Hofmann's bromide reaction, nitrene is not formed. So answer is correct, AC. Here, what is the product?
Benzyne.
So this compound is simply heated. Now, when you look at this compound, it is very clear what is going to happen. It's a very easy question. When you heat it, it will definitely undergo decomposition, and this part will give you nitrogen gas, this part will give you sulfur dioxide gas. So mechanism will be something like this. So we get benzene, nitrogen, and sulfur dioxide. Now, one of the products has 4 sp2 carbon and 2 sp carbons. You know, in benzene, all the 6 carbons are sp2. We do not have any sp carbon there. So option B is correct. Through lime water, that lime water becomes milky, that is sulfur dioxide. And last option is one of the products is aromatic and so highly stable. The benzene is aromatic, but is it stable?
No, sir.
No doubt. Benzene is aromatic, but is it stable?
No, sir.
It is not stable. So even though it is aromatic, it is not stable. do it firstly. Completed. Have you done it? Okay, so compound A, I think this everyone has got. Which compound is that? This is primary alcohol. When primary alcohol is heated with acidic potassium dichromate solution, the product will be carboxylic acid. So you will have this carboxylic acid. That is compound A. Now this carboxylic acid is reacted with sulfonyl chloride, thionyl chloride. You know, whenever carboxylic acid is reacted with this chloride, thionyl chloride, acid chloride will be formed. This will be the product. Now it is reacted with dimethylamine. Now acid chloride will react with dimethylamine and nucleophilic acyl substitution reaction will take place. The mechanism of nucleophilic acyl substitution is known to you. I will write it directly. This will attack on this carbon. Pi bond will move to oxygen. Their negative charge will come. That will come back, and then this chlorine will go out as leaving. Positive charge will be there on nitrogen. So this will happen, but see this question, they have mentioned here 2 moles. This reaction has taken place with 1 mole only. So can anyone tell what is the use of other mole? Or how will you write?
The hydrogens.
That second mole of amine that will remove this acidic hydrogen. You know, in this reaction, this acidic hydrogen is getting removed by that amine only. So this second mole of amine which they have mentioned there, that will be removing this acidic hydrogen. So I will write it here. That another mole of amine that will remove hydrogen from here. Then you will get this product. This was the product C, and after that I think it has been reacted with lithium aluminum hydride. What is the product? Anyone? What reaction will happen now?
Reduction of amide.
Amide will be reduced. So it will reduce to what?
Alcohol and amine.
You will get alcohol also.
No, sir, only amine will get.
Only amine is good.
When amides are reduced with lithium aluminum hydride, the product is amine. You won't get alcohol. This is the product. So this is the final product.
Sir,
Yeah.
sir, here the tertiary group will not affect any of these reactions, no, sir?
Tertiary group.
Will not affect any of the reactions, no, sir? Like,
No reaction is happening closer to tertiary group. No?
okay, sir.
Functional group is there, all the reactions are happening at the functional group.
Sir,
Yeah.
sir, hydride will add on that amide, like during reduction of that amide, sir, like hydride will add nucleophilic acyl substitution only, sir.
This amide reduction.
Yes, sir, yes.
Hmm.
So, like when you are adding hydride, sir, you have to do nucleophilic acyl substitution only, sir, in this case.
Okay, you want to do this way.
Yes, sir.
So what will you get then?
Then again, the group should leave, no sir, any leave.
So this NH2 we are removing as NH2 minus.
Yes, sir.
Does it behave as leaving group?
Okay, sir, understood.
Amides are very, very strong base. They do not
Okay, sir.
behave as leaving group. When amide RCONH2, this is reduced with lithium aluminum hydride. This is a method of preparation of amine. Once you revise it, now see one more question. Out of these four, you have to identify the compound which will undergo diazotization most easily with nitrous acid. What is the answer?
C.
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 Is the answer C? Is it confirmed or
Sir, A, sir.
A, sir, answer.
answer is A?
A, sir.
Yes, sir, yes.
See, there are two reactions. One is diazotization and other is diazo coupling. So actually in diazo coupling reaction, what kind of group on benzene will increase the reactivity?
Electron donating.
Electron
I'm
withdrawing.
talking about diazo coupling.
Electron withdrawing.
In
Withdrawing.
diazo coupling reaction, that coupling reactions, electron withdrawing groups that increase the reactivity. So in diazo coupling, it is electron withdrawing that is going to increase the reactivity. But in this reaction, diazotization reaction, this reaction is formation of diazonium cation. In this diazotization reaction, it is electron releasing group that increases the reactivity. So in diazotization, remember this point, in diazotization, electron releasing group will increase reactivity. But in coupling reaction, electron withdrawing group increases reactivity. So here answer is going to be C. So this diazotization reaction, do you remember the mechanism? What kind of reaction is this? diazotization reaction is ES reaction, where electrophile attacks on benzene ring. Obviously, this will never be facilitated by electron withdrawing group. So it has to be electron releasing group. Okay, we'll meet in the next class again.